Hello everyone. Okay, let's start with the introduction to the course. Okay, this is a course on automotive technologies at Kasetsat University. Okay, there are this course. Okay, the whole material is divided into two parts. Okay, the first one is the introductions and all the engines related systems in the car. Okay, the second part is anything other than engines. Okay, Al- uh, most of them are under the cars. Okay, like suspension system, like steering system, okay, brake, okay, and transmission system. Okay, basically the power transmission system that transmit power from engine to the drive wheels. Okay, we have two handouts. Okay, two parts of the handouts. Part one is the first part or the first half of the class. Okay, part two is the second half of the class. Okay, so the basic part of a car, okay, is, okay, of course, first, okay, you have to have a place for passengers. So therefore, we have this body, okay, the car body, okay, which is a metal sheet uh, combined into the body of the car. Okay, it create the shape of the car. It create the passenger compartment that passenger can sit. Okay, it create the engine compartment. Okay, that we install the engine there. Okay, we also have frame. Okay, frame is basically the structure of the car. Okay, some cars have a frame look like this. So all the weight on the car, okay, is put on the frame. Okay, is applied on the frame, so it carry the weight of every component of the car. Okay, so that almost all the component of the cars. Okay, so that's the frame. Okay. In some country, okay, or in some English, like British English, okay, you might hear the word chassis, okay, that cover the frame and all the suspension system. Okay. Next we have engine. Engine is a power source of the car. Okay. Of course, when you want to drive the car, when you want to push the car forward, you need power. Okay. Therefore, we have this engine to create power. So the power comes from the fuel. Okay, we have fuels, okay, or different type of fuels. Okay, and then we burn the fuels, and then we get energy out of that. Okay, when we burn fuel, it create heat and pressure. So that's energy, right? Okay, engine cannot operate alone because it need fuel, it need air, it need like how you ignite the fuels. Okay, it need the cooling system. Okay, therefore engine also have to be working with engine supporting system or engine system. Okay, we have a lubrication system because we have a lot of component moving inside the engines. Okay, there is a cooling system because we know that when we burn fuel, okay, most of the energy go into heat. Okay, part of the energy go into power. Okay, so we need to remove that heat from the engine, so cooling system. Okay, we also have the fuel system that provide fuel into the engine. Okay, both fuel and air into the engine. Okay, we also have ignition system. Okay, the way to ignite the the fuel. Okay, if you are using the gasoline engine. We also have electrical system that support the engine. Okay, those are the starting system and charging system. Okay, in cars we have battery. This battery is basically used to start the engine. Okay, and provides power to some electrical components such as radio, front headlight, okay, passenger light. Okay, so that battery is basically used for starting the engine. Okay, so we have starting system that take the power from battery and start the engine, and then we also have the charging system that charge the battery back. We charge the charge back to the battery. Okay, we also have powertrain. Okay, powertrain is a power transmission system from engine to the drive wheel. Okay, some car is driven using the rear wheels. Okay, some car is driven using the front wheels. So there are front wheel drive and rear wheel drive. Okay, we have to have the power transmission from engine to that drive, including gear, okay, the transmission box or gearbox, the propeller shaft, the drive shaft, and some gears set, okay, for that. Okay, so we also have chassis. Okay, chassis is basically the system under the car. Okay, it's combined. Okay, it combines the suspension system, the steering system. Okay, when you want to turn the car, and then the braking system. Okay, so those are the basic system inside the car. Okay. So first, we talk a little bit about the body of the car. Okay, the body of the car has two functions. Okay, which is allow passenger to ride in comfort. Okay, you have to have a room for passenger. You have to have a very nice seat for passenger. Okay, and then the body also protect passenger in a crash, like this picture. Okay, every car before the model go into production, you have to pass crash test, such as this one. Okay, basically they pull the car and then they crash the car into a solid wall like that. Okay, and there is a dummy inside. Okay, so you have to create a strong body because you have to protect passenger in the crash. Okay, you don't have to protect the engine. Okay, you don't have to protect the storage compartment. You have to protect the passenger. Okay, so those are the key function of the body. Okay, and there are features that we want from the body. Okay, the first feature is that it should have smallest possible wind drag. Wind drag is the force created by the air outside that push the car back. Okay, as the car moving into air, okay, it create high pressure in the front and low pressure in the back. Okay, the feature that we want to have for body is that it has low drag coefficients or drag force. Okay, so that's why you see the car with very uh, slender body. Okay, with very small front in the front. Okay, uh, we also would like to have another feature which is lightweight. Okay, because the weight is the one that use or cause the energy usage. Okay, when we want to reduce the energy use, we have to first reduce the mass, because mass, when we want to move the mass, that mass require energy to create accelerations and velocities. Okay, so those are the two features of the body. Now the body can be grouped or can be classified into many types. Okay, you can group or classify by wheelbase. Okay, basically the wheelbase is the distance between the front wheel and the rear wheel, or the front axle on the rear axle. Okay, this is the wheelbase. If you have small wheelbase, so your car is small, okay, it is classified into subcompact or compact car. Okay, compact car is like Toyota Vios. Okay, it's just like a Honda City or Honda Jazz, right? Now it go into intermediate level. Okay, a little bit longer wheelbase. Okay, such as Toyota Corolla and Honda Civic, right? So that's intermediate car. Okay, you also have full size car. Okay, full size is, for example, Toyota Camry and then the Honda Accord. So those are the full size car. The body also be classified by body style. Okay, there are many body style. Okay, to uh, match with the customer requirement. Okay, depending on uh, the person or the customers. Okay, they want different functions. So you might want a small car if you want to drive only in the city. Okay, you can have the uh, full size car like that. Okay, or the sedan. Okay, we call it sedan. Okay, you can also get one sport. Some customers also want sport car. Okay, you can sit only 2 person in there. Okay, some person want to carry a lot of things inside, so they might want a SUV. Okay, somebody want to carry a lot of constructions materials, so they want pickup truck. Okay, so there are many body styles. Okay, it just created, okay, to answer the customer requirement or customer demand. Okay, now the body also have small components. Okay, it has I mean the body can be separated into small parts or small components. Okay, these are the uh, names of different parts of the body. Of course, you have roof. Okay, for passenger compartment, you have door to get in and get out of the cars. Okay, you have this front hood, okay, to cover the engine compartment. Under there is an engine compartment. Okay, you have fenders, okay, to cover the side of the cars. Okay, you also have trunk to put to open and put the storage things in there. Okay, so there are many different parts of the body. Okay, each part also have its functions, right? So we design them, right, such that it can answer that requirements. Okay, the picture on the picture above, okay, I believe it is the US English names. Okay, the picture on the bottom is the UK, okay, the British English name. Okay, there are different words for car component or body component. Okay, for example, the front hood in US is called bonnet in the UK. Okay, the trunk in the US is called the tailgate in the UK. Okay, the fender is called front wing in the UK. Okay, there are also some Thai word. Okay, for example, okay, the hood is กระโปรงหน้า okay, the trunk is กระโปรงหลังหรือกระโปรงท้าย okay, the door is the same ประตู okay, the fender, okay, in Thailand we call บางโคลนหน้าบางโคลนหลัง okay, so if you are working in Thailand, if you're gonna be working in Thailand, you have to know all of this word because we have to communicate with foreigners. Okay, so you have to know what hood is, what bonnet is. You have to talk to Thai technicians, so you have to know the Thai word for those. The next component of the car is frame. So frame is basically the strong steel structure that support the weight of the entire car. Okay, except some weight like wheels, like tire. Okay, but most of the weight is supported by this frame. Okay, there are different types of frame. Okay, the first one, okay, the car design is body over frame. So body and frame are two separate parts. We put body on the frame. Okay, we put engine on the frame. We put everything on the frame, and the frame sit on the suspension system. Okay, so this style is still used for pickup truck and big truck. Okay, because those cars, okay, is easily, or sometimes the user or the customer can modify the car, can modify the body of the car to match with their demand, to match with the job they are doing. Okay, so that's body over frame. Okay, pickup truck is like that. Okay, but passenger car, okay, for passenger car, instead of having body and frame in separate parts, okay, they combine them together and reduce the weight of the car or reduce the weight of the whole thing. Right? In this type, we call it unitized body. Okay, or you may find the word monocoque is the word that they normally use in the field. Okay, it's monocoque body. So monocoque body is basically the frame and the body combined together, and they are I mean the whole thing or the whole body, the monocoque body is created by the metal sheet. Okay, the sheet of metal and then they stamp them. I mean, they use a stamping machine, okay, to create the shape that make it strong. Okay, so those are the monocoque body. Okay, this one is, of course, you don't have the frame under the body, so the body can be uh, have a lower floor. Okay, it can reduce the weight of the car, and it can lower the production cost. Okay, so this is the two main types of the car body. Okay, most of the passenger car or the sedan, okay, use this monocoque body. Okay, the pickup truck use that, the big truck use body over frame. Okay, so they can modify the body as they want. Okay, to store anything. Right now, these two types, you need an expensive machine to make the body. Okay, you have to have big stamping machine. Okay, you have to invest a lot to create the body. Okay, therefore, if you want to make a prototype or special type of cars or your design of car, okay, you have an option of using the tubular space frame. Okay, this is a space frame. Okay, basically it use tubes, okay, metal tubes, okay, and weld them together. Okay, welding the metal tubes together, okay, to provide the stiffness or provide the strength of the car. Okay, this is example of a space frame car, which is antique uh, sport Mercedes Benz. I believe the model is 300 SL. Okay, which has the gull wing. Okay, the door that open to the top like that. Okay, you have to uh, push the car up. Okay, to go get in and out of the car. Okay, that's SL. Okay, now the body design nowadays, okay, the monocoque design. Okay, because they want to protect the passengers. Therefore, the passenger compartment is normally made of the high strength steel. Okay, high strength steel. Any part that is not passenger compartment, okay, you can use just soft steel, such as the storage compartment, the trunk compartment, and the engine compartment. Okay, you only need some part that has a high strength. Okay, for the crash. Okay, so this is how they design the the monocoque body now. Okay, they use different type and different design. Okay, just to provide function that they want. The next part of a car is engine. Okay, this is for ICE car. So the engine has function to develop power to move the car. Okay, it do that by taking the energy from fuel, burn them, and then get power. Okay, most common type that used in cars is internal combustion engine. Okay, so basically we combust fuel and air internal inside the engine. Okay, this is a picture of engines. So basically you combust inside. Okay, inside you cannot see it from here. Okay, you see the pulley and belt here is used to drive other auxiliary component or any component that work with the car. Okay, basically the combustion occur inside. The air coming in here and go to each part of the cars, of the engines. Okay, and then it burn inside. Okay, so engine can be located in different part of the car. Most of the car has engine in the front, so we call it front engine like that. Okay, front engine like that. Okay, you can put engine along the direction of the car. Okay, we call it that longitudinal engine. Okay, the engine is put in this direction. Okay, you can put engine in this direction also. Okay, that's a transverse engine. Some cars, okay, are this front engine can drive the rear wheel. Okay, so that's we call rear wheel drive. Okay, or the engine can drive the front wheels. Okay, we call that front wheel drive. Engine can also drive four wheels, okay, all of the wheels of the car. So we call that four-wheel drive or all-wheel drive. Okay, so most of the car that drive the front wheels, okay, is transverse engine because it's easier to design the powertrain. Okay, because uh, the shaft, the engine shaft, have the same direction as the front wheels. Okay, if you want to drive the rear wheel, normally you use longitudinal engine. Okay, if you open the hood of the engine, the front hood, okay, you can tell this is transverse engine, so it is most likely that this car is driven by the front wheel. Okay, this is longitudinal engine. Okay, this is a Toyota's sport car, so it is driven on the rear wheels. Okay, there is also another type of cars or uh, a special model of the car that put engine on the back. Okay, just like this Volkswagen, okay, Volkswagen Classic Beetle, they have engine in the back and drive the rear wheels. Okay, the reason that most of the car do not put engine in on the rear because it needs air from the front. Okay, the engine need air to cool. Okay, to remove heat from the engine. Okay, from the cooling system. So it need air. That's why we put engine in the front, so that there is a lot of air pushing inside the engine compartment. If you put engine in the back like this, in the rear, okay, you may have problem with the cooling system. You cannot find enough air to cool the engine. Okay, inside the engine, okay, there are many parts that combine together and make engines work. So the basic part inside the engine are the cylinder. Okay, the cylinder is basically it is a cylinder. Okay, it is basically a tube. Okay, a big tube. Okay, that close on the top. Okay, so that's cylinder. Okay, it's a cylindrical shape. Okay, you also have pistons. Okay, which is a part that can be moved inside the cylinder. So piston can move up and down inside the cylinder. So we need cylinder and piston because we want to combust fuel inside and get power from that. Okay, we know that when we combust fuel, it create heat and the gas expand. Okay, the combustion expand. Okay, if we have uh, some kind of fuel, okay, it expand more. Okay, some kind of fuel is expand less. Okay, for example, if you want to create a hydrogen bomb, okay, you can put hydrogen at high pressure and air at high pressure and you just ignite them and then it can explode like that. So that pressure, we can use that to create power. So we put this piston, which can be, we can move inside the cylinder, and then we put fuel and air inside this combustion chamber. When we burn the fuel, it creates pressure, right? Heat and pressure. That pressure can push the piston down, and piston can move. Okay, that's work that we can get. Okay, that's power, mechanical power that we can use. Okay, when piston move down, okay, that's power. Now that linear movement is difficult to use. Therefore, we want to transform that movement, okay, up and down movement into rotational movement. Okay, therefore piston has to be connected with this connecting rod. And that connecting rod is connected to this crankshaft, which is basically the engine shaft, okay, the main shaft of the engines. Okay, so this is a bearing. Okay, this can be rotate, this can rotate. Okay, when piston move up and down, okay, when we connect to connecting rod and crankshaft, okay, you can transform the linear motions into rotary motion. Okay, so that's why we need cylinder, we need piston, we need this volume. Okay, we call it combustion chamber. Okay, we also have connecting rod and crankshaft, and then we get power. Okay, with the rotating shaft, we have a shaft that is rotating with power, which means it has speed and torque. It has speed and torque. Okay, this is a 3D picture of piston and connecting rod and crankshaft. Okay, and this is the main shaft. Okay, because this power doesn't come like continuous power, so we need this flywheel, okay, that provide inertia to keep crankshaft turning smoothly, because inertia can collect energy and it can provide or give back that energy. Okay, the normal engine that we use is four-stroke cycle engine. Okay, four-stroke cycle engine. Okay, the name and the word stroke mean when the piston move from top to bottom, we call one stroke. When it move from bottom to top, we call it another stroke. Okay, the top part, okay, the topmost part of the piston is called TDC. Okay, stand for top dead center. Okay, top dead center. Okay, this is bottom dead center, so it's the lowest part of the pistons. Okay, piston move between BDC and TDC. Okay, and one move is stroke. So the engine is four-stroke cycle. It means that, okay, after four-stroke, engine go back to another cycle. Okay, one cycle contain four stroke, one, two, three, four, and then it go back to the previous stroke. Okay, the stroke of the engines are, the first one is intake stroke. Basically, we want to combust air and fuel inside, so we have to intake air and fuel inside. So this intake stroke, basically the piston move down. Okay, when it moves down, it creates larger volume, which means lower pressure. So it creates vacuum inside, in vacuum in this volume. Okay, the vacuum also draw in, okay, air and fuel. So this is piston move down, it create it create vacuum. Okay, this intake valve open and let the air and fuel go into the cylinder or go into the combustion chamber. So piston keep moving down until it gets to the bottom of the bottommost of the pistons. Okay, now we get air and fuel inside the cylinder, inside the combustion chamber. The next stroke is the compression stroke. Okay, in compression stroke, the piston move up. Okay, everything closed. Okay, this valve is closed, this valve is closed. Okay, and we compress air fuel mixture. Okay, we compress it such that it has higher pressure. Okay, we do that because when you create pressure before you combust, okay, you get more a lot expansion. When you get more expansion, you get more power or you get more energy out of the combust out of the combustion. Okay, so that's why we have to compress and fuel mixture. Okay, because we want more expansion, we can get more expansion. So we compress and fuel mixture. Okay, for gasoline engine or for benzene engine, okay, we compress to about one part, one, I mean, 1 in 8. Okay, one out of 8 part. Okay, from 8 to 1. Okay, then after that we ignite air fuel mixtures. Okay, for gasoline engines we ignite it using the spark. Okay, so we have system to create a spark at the right time. Okay, after it combusts and fuel combusts, okay, it expand, okay, and it create heat and it also create pressure, and then it push the piston down. Okay, so pressure push the piston down, so that's where we get pressure. Okay, we call that stroke power stroke. Okay, so intake, compress, power, and then after that, after we get power, okay, inside the cylinder becomes burn gas. Okay, basically burn gas is a gas that already burned, so we cannot do anything with it. We cannot burn it anymore. We cannot use it. Okay, mostly it's a combination of water and carbon dioxide and some nitrogen and some carbon monoxide, right? So that burn gas we cannot use, so we have to remove it out. Okay, we can have to push the gas out, so we have exhaust stroke. This exhaust stroke basically piston move up, the exhaust valve open, and then we remove all the exhaust gas. Okay, we call that exhaust gas. Okay, the gas that already combust. Okay, and then after that we have empty the combustion chamber, so we go back to the first stroke. We go back to the intake stroke. Okay, as you can see, okay, with this four stroke, you only get power during the power stroke. Okay, intake, compress, and power, you get only one. Okay, you get power only in this stroke. The other three stroke, you use power. You use power to draw in the air and fuel. You use power to compress gas. You use power to push the exhaust gas out. Right, so we only get one, let's say one pulse of power like that. So normally in the in typical engine, okay, you have more than one cylinder, and each cylinder create power at different time, right? So maybe cylinder one and then go to cylinder three, go to cylinder four, go to cylinder two. Okay, so it create power at different time, so that we get continuous power. Okay, in this picture is six cylinder engines. It can have six cylinder, one, two, three, four, five, six. Okay, and each cylinder have different timing for piston to power or to ignition to for us, I mean for the engine to ignite the gas. Okay, it has more than one cylinder. Okay, therefore the crankshaft is designed so that different stroke occurring at different time. Okay, so that's the engine. Okay, now because engine, okay, as I said, need fuel, need air, need ignitions, create heat, and have exhaust. Therefore, we need some supporting system to work with the engine. So it requires several supporting systems. First one is lubrications, because engine has moving parts, cooling to remove heat, fuel to provide air and fuel, ignitions to ignite air and fuel mixture, and then emissions, okay, to take the exhaust gas out. Okay, we want to take them out so that it is have very quiet. Okay, so that it don't create a lot of noise. Okay, so that it do not release bad gas. Okay, or we call it pollutant to the air, to the atmospheric, to the surrounding. Okay, so we need emission system also. So basically the lubrication system, okay, just introductions. We will go into more detail into when we go into the lubricating system lecture. Okay, so lubricating system basically we use oil. We need lubricating oil. So we put lubricating oil in this oil pan under the engine. Okay, that's the lowest part of the engines. Okay, we use this oil pump to pump the oil, and then we send the oil through the filter so to clean the oil, and then we put the oil everywhere. Okay, we put the oil everywhere. There are like small tube inside the engine that send the oil, okay, to many place, any place that we need lubrications, okay, such as the crankshaft, such as the valves moving, so the valves train. Okay, so those are lubricating system. Okay, those are the component of lubricating system. Okay, so it prevent metal to metal contact. It also used to carry heat away from those area. Okay, the cooling system is basically regulate and control engine temp. Okay, regulate and control engine temps by removing heat. Okay, so basically we circulate water inside the engine. So there is a passage of water. Okay, there is like a big space or volume of water, and that water can flow inside the engines. Okay, it flow around the cylinder. So after fuel combust, it create heat. The heat go out, and there are water to pick up. There are water flow to pick up heat. Okay, so this water flow to pick up heat, and then it goes out. It go out this way. Okay, and then the heat in the water, in the cooling, in and the coolant. Okay, in the water coolant is removed inside this radiator. Okay, to the air that coming in from the front. Okay, so the air coming, it go to this radiator. It remove heat from the water or from the coolant, and then the hot coolant become cold coolant here, and that cold coolant go into the engines, and then it pick up heat, and it go out to the radiator just like that. Okay, the fuel system is basically, okay, provide fuel storage and deliver fuel and air into the engines. Okay, and also mix air with fuel. So what you have is you have fuel tank under the car. Okay, when you fill in fuel, okay, the fuel goes into the tank like that, and then there is a fuel tube. Okay, this fuel tube or fuel line. Okay, uh, there's fuel pump inside the fuel tank that pump the fuel to this fuel line or fuel tube to the engine. Okay, and then this fuel injection system is one of the type of the system that combine fuel and air. So it inject fuel into air, okay, to mix fuel with air, and then the mixture go into the engine. Okay. We also have ignition system inside the car. Okay, basically you have to create spark. Okay, the spark is created by this spark plug. Okay, basically you need high voltage electrical source, and then you create a gap between two electrodes. Okay, you have one metal and the other metals, and you provide current. Okay, provide high electrical uh, voltage into one of the electrodes. Okay, when you provide that, you can create spark. Okay, you can create a spark in the air, right? So that's a spark plug. Okay, that's why we need this ignition coil to create high voltage electricities. Okay, and we get that coil, we get the electricity from battery. Okay, so that's ignition system. Okay, so these are the component inside the ignition system. Okay, we can skip that for now. We also have electrical system inside the car, okay, which used to start the engine. Okay, so that starting system crank, so rotate the engine fast enough for engine to start. Okay, as I said before, okay, engine has intake stroke. Okay, to create that intake stroke, you have to pull the piston down, or you have to rotate the crankshaft. Okay, if engine stop, you cannot create that intake, right? So we have to start rotating the engine so that piston move down. Okay, after the piston move down, you can create an intake stroke, and then if you can move the piston up, you can create compressed stroke. And then after that, you can burn, you can ignite the fuel, and then engine can create power by itself. But before that, the intake and compression stroke, you have to find a way to create those two strokes. Okay, or you can rotate the engine. So you rotate that engines using this starter motor. Okay, it is a small motor, okay, about this size, okay, that connect to the engine flywheel, okay, engine shaft. Okay, this is the engine shaft. Okay, and this starter motor get power from battery. Okay, using this solenoid or uh, relay. Okay, relay. Okay, with this system. Okay, after that, okay, to start the engine, you use power from battery. Okay, you have to charge the battery back using this system. Okay, we're gonna talk more about that. We also have powertrain, right? So So basically, okay, after you create power using your engine, you have to transfer power to the drive wheels. Now, the power that you create from the engine is not the one that we want, or the characteristic of the power from the engine is not the one that we want at the drive wheels. Okay, engine has high speed but low torque, but we want high torque at low speed, so we have to transform the power using these transmissions. Okay, the transmission is basically the sets of gear. Okay, there are many sets of gear inside the transmission. Okay, we also have to find a way to disconnect engine from the wheels or connect engine to the wheels. So that's the clutch. Okay, this clutch is basically this picture. Okay, we're gonna talk more about that. Okay, and transmissions, and then we also have differentials in here to transmit power or divided or divide power into right and left drive wheels. Okay, we also have chassis. Okay, the chassis or chassis, okay, provide ride control and allow driver to steer and stop the car. It is made up of suspension system. So basically, the suspension system is a spring, okay, that absorb the vibration from the ground, okay, or from the wheels, and absorb that vibrations or absorb that shock into the springs, and also the 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 shock absorber. Okay, so that the passenger do not shake like the roads, okay, like the wheels. Okay, the wheel can shake, but the passenger cannot shake. Okay, we also have steering system. Basically, when you turn the steering wheels, okay, this thing is called steering wheels, the thing that the driver turns. When the driver turns steering wheels, the front wheel can turn right and left. Okay, so there is a system for that. We call it steering system. So it, let's say, it transfer the movement of the steering wheels into the front wheels. Okay, we also have braking system. Okay, when drivers step on this brake pedal, basically we have to create a pressure. We have to create pressure at the braking pad. Okay, we call it brake pad inside this brake pad. So it's braking system inside. Okay, basically it make let's say it use frictions to slow down the wheels. Okay, to slow down the wheels such that we can stop the car. Okay, and we also have tire and wheels. Okay, this combination of the chassis. Okay, so that's the introduction to the class. This is what we're gonna learn. Okay, we're gonna talk about more about engine and engine component and engine constructions. We're gonna talk more about the lubricating system. We're gonna talk more about the ignition system. Okay, about the gearbox, about the differentials, about the shaft. Okay, we're gonna talk more about the steering system. We're gonna talk more about the braking system, right? In this class. Okay, so this is the last slide now. Okay, so that's it for this lecture. Okay, the introductions to automotive technologies at KU.